these are the notes for 7-3. We're going to start with a little review of what we did yesterday. I apologize about this thing. I don't know how to make it go away. So what I would like you to do is read these. They are on your notes that the teacher provided. So read through these with your group. Discuss your answers for true and false. When you have agreed and discussed them all, then you may unpause and continue and check your answers. So please push pause now and work through this with your group. Okay, these are the answers. Every parallelogram is a quadrilateral. That is true. Parallelograms all have 4 sides. Every quadrilateral is a parallelogram. That is false. Not every quadrilateral has both pairs of opposite sides parallel. All angles of a parallelogram are congruent. This is false. They could be, but they aren't always. In order to say true, it has to always be true. And there are times that happens, but it doesn't happen every single time you make a parallelogram. The same reason for the next one, all sides of a parallelogram are congruent. That is false. That can happen sometimes, but it doesn't happen all the time in a parallelogram. In the one below that, you'll notice I drew a little diagram there. I talked to you about this yesterday. Please make sure that when you label your diagram, the order of the letters is going around in a circle. That'll help you be able to identify the sides. So is RS parallel to TU? Yes, that would be true because opposite sides should be parallel in a parallelogram. In parallelogram ABCD, so again, notice how I labeled this. In order, going around in a circle. If angle A is 50, then angle C would be 130. That is false. A and C are opposite angles. They should be equal. I apologize for this thing. XWYZ, I have that labeled here. So XY would actually be a diagonal, and WZ would be another diagonal. There are times that the diagonals are congruent, but that's not all the time in a parallelogram. They always bisect each other, but they're not always equal. In parallelogram ABCD, again, notice the labeling. AC and BD bisect each other. That will be true. Those are diagonals if you look at the diagram, and they will always bisect each other. So today we're going backwards from what we did before, where we are going to prove that quadrilaterals are parallelograms. Yesterday I said this is a parallelogram. You said, oh, that's a parallelogram. Here's lots of information I know about that. Today I'm going to give you a quadrilateral, and I'm going to give you information about that quadrilateral, and you have to determine if it is a parallelogram. There are 5 ways that we can do that. If you have both pairs of opposite sides are parallel, and you can show that or you can see that in the diagram, then your reason that it is a parallelogram would be the definition of a parallelogram. It meets the definition. If you can show that both pairs of opposite sides are congruent, your reason would be if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. You'll see I shorten that up a little bit in some of the examples we do later. In number 3, one pair of opposite sides are congruent and parallel. What I need to bring up with number 3 is that they have to be the same set of sides. You can't have one set parallel and then the other sides being congruent. You can actually make a trapezoid that way. That's why I can show a counterexample to prove it can't always be a parallelogram. So if you're using number 3, make sure it's the same set of sides that is congruent and parallel. In number 4, you could show both pairs of opposite angles are congruent, and number 5, you could show diagonals bisect each other. So 1, 2, 4, and 5 are all converses of things we learned in theorems we did yesterday. So in the first one, I'm giving you information about this quadrilateral, and you are to state the principal definition or theorem that enables you to deduce from the information given that ABCD is a parallelogram. So if you look at these, what basically you're doing is matching these to one of the blue phrases or words here. So I'm going to give you some time to work with your group on that. So go to here in your notes. Again, you can refer back to the slide before that with the theorems and definitions. And I would like you to push pause and put your answers here now by working with your group. So push pause now. All right, these are the answers that you should have. Again, apologizing for this watermark. And you can see where I abbreviated a little bit and kind of made it my own words. So if I'm moving too quickly, just push pause if you need to check. but these are the answers to that slide. Over here, these are actually two problems, so be careful here. This right here is one problem, and then this down here is another problem. So there are two problems on here. Again, I encourage you to work with your group. Please push pause, work through these yourself. You'll learn it better by trying to do it yourself, and then come back and check your answers. Please push pause now. All right, these are the answers. You can see 360. We learned a couple days ago that a quadrilateral is 360 degrees. I subtracted all the angle measures I had and found that the fourth angle was 138. And then I could show that it is a parallelogram because I proved the opposite sides, or I'm sorry, the opposite angles are both congruent. All right, for what values is this the quadrilateral parallelogram? Well, in order for it to be a parallelogram, opposite sides have to be equal. So you can see I set that up here. Opposite sides have to be equal. I substituted my answer of 10 from the previous problem in to get that answer. All right, here's a new problem. Please push pause, work through, and then come back and check. Here are the answers to that one. As you can see, I need to make the opposite angles congruent in order for it to be a parallelogram. So I did that here and here. So I found x is 32 and y is 29. And I explained these values will make the opposite angles congruent. All right, try this one. Push pause. All right, answer. Well, I can see that CE is already being bisected because it's broken into two congruent parts. So I need to find an x so that FN and ND will be equal. So I did that by setting the two parts equal, solving for x. If x is 4, then FN and ND will be equal, and I will have both diagonals being bisected. All right, over here, you can do this. Push pause. And here are your answers. Again, if you need to push pause and double check your answers, you're welcome to do that. And number 6, apparently I'm just going to give you the answer for that one. That's similar to the one we did before. I can see QN is already bisected, so I have to figure out what X value will make sure that MP is being bisected. I set the two parts equal, so X equals 2. All right, please check the announcement for the homework that you need to do, and that completes our notes for today.